This is the PSOJ 38.522, a rogue planet wandering alone in the dark space. It has no star to orbit, no planets neighboring, and not even a single moon. Nearest planet, or star to PSOJ 38.522, is 3 light years away. It is wandering alone in space for millions of years, and there are thousands of other rogue planets like J3825 in our universe. Welcome back, my friends. Today we will discuss about the rogue planets, or the lonely planets, of our universe. We will discuss about how do they form and why they are alone. So don't skip this video, because this video is going to be very interesting. Let's talk about what is a rogue planet first. The rogue planets, also known as interstellar or free-floating planets, they do not orbit a star and drift through space independently. These planets can be found in the vast expanse between star systems, unbound to any stellar gravity. Finding a rogue planet in this huge space can be challenging, because they don't emit any light and they are far from the illuminating presence of stars. Now imagine you are trying to find a little black dot moving at the speed of 100,000 kmph in this huge black universe. It's hard, right? But still, astronomers managed to find some rogue planets. As of December 2021, the largest ever group of rogue planets was discovered, numbering at least 70 and up to 170, depending on the assumed age. One of the primary methods used to detect rogue planets is gravitational microlensing. This occurs when a rogue planet passes in front of a distant star, causing the planet's gravity to bend and amplify the light from the star, creating a temporary brightening effect. Another method involves infrared surveys, which can detect the faint heat emitted by these planets. Space missions like NASA's Nancy Grace Roman Space Telescope and ground-based observatories like the European Southern Observatory's VISTA have been instrumental in discovering and studying rogue planets. Now let's talk about how they formed. These planets can form in the same way as regular planets. They form in a solar system, just like our 8 planets were formed millions of years ago. But somehow they ejected from the gravity of their host star and start wandering around in the space alone. Sometimes a star system didn't need it for formation of a planet, because there are millions of gas and dust clouds in the interstellar space. And the process of collapsing of the dust clouds is similar to star formation, but does not accumulate enough mass to initiate nuclear fusion, resulting in a planet rather than a star. Now we know about the formation of a rogue planet, but how do they eject from the star system? Just stop scrolling for a minute, and let me answer it. Rogue planets can be ejected from a star system through several mechanisms. Gravitational interactions. Close encounters between planets within the same solar system can result in one planet gaining enough energy to be ejected from the solar system. This happens in young, dynamically active planetary systems, where large planets can exert significant gravitational forces on each other. Stellar flyby. A nearby star passing close to a solar system can disturb the orbits of its planets. The gravitational pull from the passing star can provide enough energy to push a planet out of its orbit, leading to its ejection from the system. Instability in multi-planet systems. In systems with multiple planets, complex gravitational interactions can lead to chaotic orbits. Over time, these interactions can result in one or more planets being flung out of the system due to increased orbital eccentricity and velocity. And the last but, the most interesting point, the supernova explosions. Yes, you heard right. A supernova can also send planets into interstellar space. In a binary star system, if one of the stars goes supernova, the sudden loss of mass and the accompanying explosion can disrupt the gravitational balance, potentially ejecting any planets orbiting the surviving star. Wow, you are still watching. It seems like you love space. Then you should watch this video too, for more interesting space information.